Good morning. We have been discussing on the water quality standards and what are the various parameters which have to be looked into to make a water potable for drinking. So domestic water supply and industrial water supply and water supply for irrigation. Usually for water supply for domestic purpose, either for residents or for townships by the municipality or corporations. Drinking water standards have to be met with. For all the contaminants, you have a permissible limit that should not exceed the actual value shall not exceed the permissible limits. Different water sources, rivers, lakes, water streams, ponds, open wells, deep wells, according to their source, according to their flow pattern, either a surface runoff or as seepage or infiltration, percolation, then coming as groundwater. And all these things, these values will change because they come in contact with all the, as far as water is concerned, we have to call them as contaminants. But all these contaminants have their own role in other processes. They may be required for other processes. So they are not universal contaminants, but for drinking purpose, once they are coming in water, if their presence in water exceeds a particular limit, then they are called contaminants as far as potability is concerned. So that contamination will be different for different water resources or water sources. For industrial water supply, there may be standards according to the type of the industry and according to the role water plays on the manufacturing process. They are individualistic, from industry to industry, from manufacturing process to manufacturing process. The water quality standards vary. We cannot generalize. But in the case of domestic water supply for potability, it is unique and it is general and very specific. You have seen yesterday the table of contents comprising of different matter or rather contaminants present in water and their maximum quantity which is allowed in water. So, the water quality standards are set and regular laboratory investigations will be made and water will be made potable either by natural means, by themselves, by normal disinfection, adding bleaching powder, or you may have to go for involved process, especially the water supply is for a town or municipality or corporation, public water supply. So there are different sequences of operation which is known as the water treatment.
In this lesson, we're going to talk about the coagulation and flocculation process. And then we're going to do a quick demonstration of just how coagulation and flocculation works. As you can see, we have here negatively charged colloids in a jar we might use for jar testing. Now, most of the particulate matter or non-sellable particulate matter in surface water carry a negative charge with them. What we do to neutralize these negatively charged particles is we add a coagulant, such as alum or aluminum sulfate. And when we add the positively charged coagulant, we end up neutralizing the negatively charged particles. And that coagulation takes place in about 1 to 2 seconds. Once the charges are neutralized, these particles can begin to flocculate together, and they start by forming what's called microfloc. And then as the coagulation process continues, they become macrofloc. And become a size they can ultimately settle out. So by mixing these negatively charged particles, we can then get them to together and then ultimately flock together. Well, once they come together, we then can add another chemical, polymer, and that polymer helps keep that floc together, and it bridges the microfloc to form a macrofloc that ultimately can be settled in the sedimentation basin. So the coagulation-flocculation process impacts the effectiveness of the sedimentation process. We'll talk about that in the next lecture. Well, here we have what's called a flocculator, and most flocculators consist of 3 distinct basins that are separated by baffles, and each flocculation chamber has different mixing energy. As you can see, in the stage 1 flocculation chamber, we have high mixing energy, where the particles are moving around very quickly. In the second stage, the particles have gotten bigger because they flock together or agglomerated, and the mixing energy gets lessened, so we have medium mixing energy. And the purpose of that is so we don't break the floc apart. And then finally, in the third chamber, we have low mixing energy, and that low mixing energy allows the floc to continue to get bigger and form a floc that will be able to settle in the sedimentation basin. And as the floc gets bigger, we want the mixing energy to be less and less, so that the floc does not come apart. So notice here, in this third stage chamber, we've seen the particles even get bigger as they attach with one another. This floc is now ready to settle in the sedimentation basin.
It is nothing but a chain of scientific actions to remove impurities from water. The contaminants can be otherwise called as impurities too. So, from the lake or from the reservoir or from the river or from any groundwater, you will get water. So, water source is known. The first and the foremost thing what we will do is, it is a process of coagulation and flocculation. So, coagulation is the process of densifying the impurities. The solid particles will be densified. They will form as a lump or mass and get settled because of their weight. You will be using coagulants or flocs, alum. Alum is the usual coagulant used in water for coagulation and flocculation to take place. Here actually, even though water quality tests were done, more of it is chemical engineering or chemistry. More chemistry is involved. The role of a civil engineer there is not that much. But once the water quality assessment is made, then the water treatment process, which is on land. Actually, that is the relevance of this topic taken after transportation and irrigation, because you need lot of space now, land, where you need the components of the water treatment plant. The total system is called the water treatment plant, and you need large area, open area, where you should have these components. First component is the coagulation chamber. It will be very huge. It is usually circular in shape, having meters diameter, 30 meters, 40 meters diameter, huge circular pond, reinforced, because its longevity should be more. So, well constructed, designed and constructed coagulation chambers or coagulation tanks. And there will be a central pillar in which you will have an arm, as you have seen in the turntable, the case of turntable railway. You will have an arm, and then you will have a vertical post, and you will have an arm, horizontal arm, which will be rotating with different speeds, slow, medium, high, like that. After adding the coagulant, so you agitate, and the flocculation takes place. Flocculation is nothing but a form as flocks or densification, and that coagulation, after a particular period of time, all the particles get settled, and you have the process of sedimentation. Next, the sedimentation. So once after coagulation, first the water source, then the coagulation or flocculation, then the sedimentation.
Once proper floc has formed, it must be separated from the water through sedimentation or clarification. This process takes place in a rectangular, square, or round tank called a sedimentation basin or clarifier. It should be noted that direct filtration plants do not include a sedimentation or clarification unit process. Solid particles are kept in suspension in water as long as it flows with sufficient velocity and turbulence. Sedimentation removes floc by slowing the flow of water and decreasing turbulence. The heavier floc particles drop to the bottom, and clarified water is collected from the top for filtration. Traditional sedimentation basins have 4 zones. 1. The influent or inlet zone decreases the velocity of the incoming water and distributes the flow evenly across the basin. 2. The settling zone provides the calm area necessary for the suspended material to settle. 3. The effluent zone provides a smooth transition from the settling zone to the effluent flow area. It's important that currents don't stir up any settled solids and carry them into this area. 4. The final zone is the sludge zone, where settled solids are separated from other particles in the settling zone. There are many variations in design for sedimentation basins. The 2 most common types are rectangular and circular clarifiers. In a rectangular clarifier, water flows across a rectangular basin. A circular sedimentation basin can be either center-fed or perimeter-fed, where water is introduced to the clarifier in the center or on the perimeter, where the water is allowed to flow unperturbed throughout the basin. Plates and tubes may also be used to increase the surface area available for settling, allowing for increased flow rates and enhanced settling in a smaller basin. As water travels up through them, instead of having to settle as much as 10 or 15 feet, particles have to settle only a matter of inches to reach the surface of a plate or tube. As particles continue to settle out and build up, they can slow down the tube or plate and eventually settle to the bottom of the basin.
In the case of sedimentation, all the particles will get settled and you will have clear water. That water from the up will spill out or flow to the filtration. So coagulation, flocculation, sedimentation, filtration. Filtration will have large pads of sand, gravel, and charcoal. There are 2 standard filtering methods. One is slow sand filter, another is called rapid sand filter. Where in filter filters, water filtering may be sometimes from bottom to top. Filtering will from bottom to top. So again, in that reverse process of coming out, again the microbial organisms also will go to a great extent. So coagulation, flocculation, sedimentation or settling, then water goes to filtration bed, large beds, rectangular beds, huge in size. All these things are civil engineering works, totally civil engineering works. And you have to frequently change the filter materials, the sand, the gravel, charcoal, everything will get clogged because of these impurities stuck to the pores. So once that clogging takes place, you have to remove them and refill. After filtration, the last process is called disinfection. Disinfection. Usually chlorination. You add chlorine. Disinfection. So coagulation, flocculation, sedimentation, filtration, then disinfection. Then they will be sent to the overhead tanks. Usually overhead tanks. In municipal and corporation, you have overhead tanks positioned at the highest place in the locality, in the town, highest place. So the water can be supplied to more people by gravity. Water can flow by gravity. So usually the highest point will be found out for locating the water tank by site inspection and survey. By detailed surveying, we will fix up a point whose reduced level, I told you what is reduced level with respect to the benchmark or mean sea level, is the highest by which it can cater the need of the people around several kilometers of the water tank. So elevated water tanks. There are different types of water tanks. Reinforced cement concrete water tanks, which will have foundations, strong foundation, mat foundations or pile foundations or individual footings or combined footings. We'll see once we come to what you call the oxygen of civil engineering known as building technology. When we come to that, we will deal that. The live wire of civil engineering is the building technology. As I have told you, civil engineering is the mother of engineering. The live wire of civil engineering. So you have a lot of water tanks, different types of water tanks. There will be huge columns. They all will be connected by circular water tanks are very common. Circular water tanks. Then square water tanks. Rectangular water tanks are rare. Usually square and circular water tanks. Then there are challenging water tanks. You have only one pillar on which you have a conical shaped water tank. Architectural, aesthetical appeal also will be there. That is what is called INS type. INTZ. INS type water tank. So INS type water tank, conical. Then you will have a vertical post. You will have a strong foundation on which this pillar will be raised, on which you will have everything will be monolithic, continuous. Then you have steel water tanks. In railway stations, pressed steel water tanks. For domestic purpose, on houses, you will have usually brick. Brick laid with rich cement mortar and plaster. Brick water tanks. You have concrete water tanks too. Concrete water tanks also possible. Nowadays you have PVC water tanks, plastic water tanks. There's a revolution in water tank. PVC water tanks you have. Those are for small domestic water supply. That water tank will be filled by the main water tank from the society, from the municipality, or from the open well having a small 0.5 HP or 1 HP. Centrifugal pump will feed to the overhead water tank. Usually the water tank will be kept at the top of the upper roof, so that you will get more force. That's a water supply scheme. So water treatment, these are the components for which you need large land and conduits, huge pipes to take water to each chambers, tanks to do their work. Then you need the dosages of coagulants. Then you need the filtering materials yard you may require. Then you may have to have a disinfection chamber. You need the disinfectant storages. Then from there you need long pipes to take the water to the water tank. And from the water tank, the pipes have to go and laterals have to go from the pipe. As you have a network of irrigation system, you need a network of pipe systems also, conduit systems also. Pipe network. A pipe network is part and parcel of any water supply scheme, either for domestic water supply or for industrial water supply. You need a pipe network to avoid losses and also to provide clean, pure water without any contamination during the process of distribution from the water tank to the people. There is every chance, suppose the pipes are open or the pipes are cracked, the pipes are having some joints, and if the joints are leaking, even after taking all these precautions and taking this involved process of treatment, again the contaminants will peep into that. So to avoid that, a well-maintained, free of defects pipe network is a must for water portability to be maintained till it reaches the end user and the end user uses the water. The average consumption of water in the domestic a person, usually it is 120 to 140 liters, 150 liters of water. You can, even though we use more water, standard says that around 150 liters of water is enough for a person per day. Per capita usage of water for one day can be 150 liters per day. You can verify whether you are using less than that or more than that. Anyway, we will continue tomorrow. Thank you very much. God bless.